Hi, so let's have another example of the integration by parts. So we say that the u dv is equal to uv minus the integral of v du. Okay, so for example, we need to evaluate x raised to 2x t of x. Okay, so once again, this integrand cannot be directly solved using our basic formulas, so we need some techniques in order for us to solve this. Okay, so using the integration by parts, we say that we need to think which is our u and which is our dv, wherein our technique, or it is suggested that the dv must be integrable. So which part here is integrable, the x dx or the e 2x dx? Okay, so both are integrable. Okay. Let's say let's let our dv as x dx and our remaining function of x is equal to u, which is e raised to 2x. Okay, let's try this one. Okay, we let this as our u and we let our x dx as our dv. Okay, so let's try if this will work. Okay, so the derivative of this u is du, so the derivative of this is e 2x, derivative of x is 2 d of x, right? Or equal to 2e 2x dx. That is our du. For our dv, so if we take the integral of dv, we will have v. Then the integral of x dx, we have x squared all over 2. Okay, so after this, we will proceed to our main formula, which is this u dv here, u dv here. This is our u. It's our u and our dv. uv is equal to u. What is our u? E to the 2x times our v. We have x squared all over 2, or 1/2 x squared. Then minus this is okay, minus the integral of v, and then our du. v du, right? So our v is x squared all over 2 multiplied by du is 2e 2x dx, right? So as you can see here, you can cancel this out because 2 over 2 is just 1. So we have x squared by e 2x. So we have, let's simplify this. We have 1/2 x squared e 2x minus the integral of x squared e 2x t of x. Okay, so let us analyze once again. So we need after this, we need to integrate this x squared multiplied by e raised to 2x then dx. Okay, So we say that when we use this integration by parts, our rule, or not the rule, rather, it is suggested that the VDU, this part, VDU, um, VDU must uh, be more simpler, or must not be more complex than our UDV. Okay, so as you can see here, this is more complex than our UDV. So maybe we should try the the um, the um, the other way around, wherein we will use e to x as our dv rather than x. Okay, since if we do this, our answer became more complex than the original one. So let's try the other uh, other other u and dv. Okay, so let's swap. Okay, so let's try another. So we let our u, instead of e to x, let's let our u is equal to x, and then our dv is equal to, instead of x dx, let's try e to x. E to x e to x, then d of x, right? Okay, then, and if we take the derivative of u, then it is the u, and the derivative of x is just the x, and the integral of dv is just v, and the integral of this one is what? So if we take the integral of this, we have e to x all over 2, right? Because the derivative of the 2x is 2, so we need to divide both sides by 2, so we have e to x 1/2. Okay, so if you need to integrate it one by one, then let's review. So we need to integral of e to x dx. Then if we let u is equal to 2x, then our du is 2 dx. Okay, and since we only have dx here, so we need both sides by 2. Yan. So we can rewrite this as the integral of e to d. Our 2x is u, and then our dx is du all over 2. Okay, so the integral of this is just 1/2 integral of e to the u, du. Then we have 1/2 e, the integral of e to the u is e to the u, or wherein our u is 2x. Okay, yan. So our integral of this is e 2x all over 2. No, okay, this is our integral, right? Okay, then after this, let's try to do the formula for the integration by parts, which is equal to integral of x e to x dx is now u v. What is our u? X, and our v is 1/2 e to x, u v, and then minus the integral of v. We have 1/2 e to x, right? V, then du, which is dx. Okay. Okay, so as you can see here, you can now easily integrate this. Okay, so the integral of this part is this one. So we have 1/2. This is the constant. Then the integral of this part, e to the x dx, is just e to x all over 2, right? So all in all, we have say 1/2 x e to x, then minus 1/2 e to x all over 2, then our plus c. Okay, or you can easily simplify this by factoring out the 1/2 and this the common 1/2. They are both and e to x. Okay, so if we have 1/2 e to x, what we have left here is the x minus the 1/2. Okay, so we have x minus 1/2, x minus 1/2, right? Okay, then our plus c. Once again, as you can see here, as suggested, we can choose dv that that is a function of x that can be integrated or integrable. But both of this function of x are integrable, so we try to let u as e to the x and dv as x dx, but we come up with a more complex vdu rather than our original integrand. So we shift our selected u and dv, so we've come up with this one, and come up with a more simpler vdu. So we can easily integrate this and then find our final answer. Okay, so once again, this is a example of the integrand that can be solved using integration by parts. Thank you.